Now let's prove the identity and find the domain. So prove the identity and state the domain of theta in each case. Well, the left hand side is tan theta plus cotangent theta. Now to prove that the left hand side is equal to the right hand side, you basically just take one side and use the identities that you learned before to prove that and basically just convert one of the sides to the other side. So we're taking the left hand side over here. Usually, again, you take the side that has the most amount of functions being added up. So basically separate functions, cosecant theta, and on the one and on the other side there's just one big function in which many different trigonometric functions are being multiplied. That's hard to prove. The ones that are being added up are easier to prove, which is why we're taking the left hand side over here, tan theta plus cotangent theta, and we'll use the identities to basically convert this into this. So tan theta plus cotangent theta, you convert tan theta and cotangent theta into sine theta over cos theta plus cos theta over sine theta. Now you'll take the LCM. So sine theta will be multiplied with sine theta, cos theta in this numerator will be multiplied with cos theta, and we basically get this. Now remember the identity that sine square theta plus cos square theta is equal to 1. So basically now you'll replace that with 1. And this basically just turns into, once you take the reciprocal of this function, that just becomes, well, not the reciprocal of it, but we know that 1 over sine theta into 1 over cos theta. So 1 over sine theta is cosecant theta and 1 over cos theta is secant theta. So that's how you've proven that the left hand side is equal to the right hand side. Now the domain of this function is basically just theta is any real number, but theta cannot be equal to any multiple of pi by 2, because sine theta becomes 0 when it is any multiple of pi, and cosecant, sorry, not cosecant, but cos becomes 0 when it is any multiple of pi by 2. And you know that 1 over 0 is undefined, so that cannot lie in the domain. So sine theta into cos theta can never be equal to 0, which is why theta cannot be a multiple of pi by 2. That also covers sine theta, because any multiple of pi by 2 eventually becomes a multiple of pi as well. So yeah, theta cannot be any multiple of pi by 2. Now, prove the identity and state the domain of theta in each case. So again, we need to prove that the left hand side is equal to the right hand side. Let's take the left hand side and prove that it is equal to the right hand side. We'll basically use the identity that secant square theta is equal to 1 plus tan square theta. So we'll replace this secant square theta with 1 plus tan square theta, and you'll use the other identity that cosecant square theta is equal to 1 plus cotangent square theta. So cosecant square theta becomes 1 plus cotangent square theta. And now basically, see, you've proven that the left hand side is equal to the right hand side by using the identities. And now you need to find the domain. Again, theta cannot be equal to, cannot be a multiple of pi by 2, because, well, you know that tan theta is basically just undefined at any multiple of pi by 2. And similarly, so is cotangent square theta. And now, let's see. Prove the identity and state the domain of theta in each case. Well, we'll need to prove that the left hand side is equal to the right hand side. So we'll take the left hand side, and basically now you can see that by using the algebraic identity that a square minus b square is equal to a plus b into a minus b. We'll use the same algebraic identity to see that secant theta plus tan theta into secant theta minus tan theta is equal to secant square theta minus tan square theta. And so you have this, and you can basically just use the identity that secant square theta is equal to 1 plus tan square theta over here. And so now you can cancel out this tan square theta and this tan square theta to get 1. And so you've proven that the left hand side is equal to the right hand side. And the domain of theta is basically just any real number because it just gives you 1.